The last bit of section 10.3 is about understanding the difference between statistical significance and practical significance. When a large sample size is used in a hypothesis test, the results could be statistically significant, even though the difference between the sample statistic and the mean stated in the null hypothesis might not have any practical significance. Practical significance practical significance refers to the idea that while small differences between the statistic and parameter stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. Let's look at an example of that. According to the American Community Survey, the mean travel time to work in Collin County, Texas in 2013 was 27.5 minutes. The Department of Transportation reprogrammed all the traffic lights in the county in an attempt to reduce travel time. To determine if there's evidence that travel time has decreased as a result of the programming, the Department of Transportation obtains a random sample of 2,500 commuters, records their travel time to work, and finds a sample mean of 27.2 minutes with a standard deviation of 8.5 minutes. Does this result suggest that the travel time has decreased at the alpha equals 0.05 significance level? So we should go through and check our requirements, but I think we've done that enough, so we'll skip it this time. So let's state the hypotheses. Our null hypothesis is that the mean travel time is 27.5 minutes. And our alternative is the mean is now less than 27.5 minutes because they were trying to decrease their result. Our significance level, we're told, is 0.05. So if we do a t-test, we need mu0, which is 27.5. Our sample mean, which is 27.2. The sample standard deviation, Sx, which is 8.5. And our sample size of 2,500 people. So if we go to our calculator, we can put all of that in. Stat over to tests, t-test, and we're back to stats again. We do not have data this time. Our mu0 was 27.5. Our sample mean is 27.2 with a standard deviation of 8.5. And our sample size was 2,500. Yes. And we want less than. Calculate. Our test statistic is negative 1.76. And our p-value is 0.0389. So t, we said, was negative 1.76. And the p-value was approximately 0.0389. So comparing the p-value to alpha, the p-value is less than because it is 0.0389. Alpha was 0.05. The p is low, so we reject the null. Because the p is low, the null must go. So if we have to state the conclusion, there is sufficient evidence at the alpha equals 0.05 significance level to conclude that the mean commute time to work has decreased. But the difference between 27.2 minutes and 27.5 minutes, we just proved that it is statistically significant, but it has no practical meaning. Why not? That's 0.3 of a minute. So that's 18 seconds. If your commute is 18 seconds faster, does it really matter? I mean, 18 minutes maybe, but definitely not 18 seconds. So that's why there's statistical significance and practical significance that may or may not be the same thing. Well, that concludes our discussion of hypothesis testing about a mean. So in the next videos, we will start talking about linear correlation.